All right, so in this chapter, we're going to look at probability, and we're going to look at a few uses of probability. It turns out probability is very much a part of your day-to-day life, even if you don't realize it. Okay, so when I say probability, I'm just talking about the chance that some event occurs. All right, now when I have an event occurring, there's always this sort of underlining probability experiment that happens. There's a chance process that leads to the result. Okay, and these can be very, very different. We tend to think of probability as being like associated with rolling a die. So if I roll one die, on our die we have the numbers 1 through 6. So the probability experiment would be rolling the actual die. And the probability of rolling a 2, well, the number 2 is one of those 6 numbers. All right? So the probability of rolling a 2 is 1/6. Or if we're talking about a fraction, it's 0.1666, and the 6's repeat. All right? Now, that's sort of the traditional way to look at that. There's a lot of other probability experiments that we could do. For instance, let's say I take medicine. So I take some medication. The probability of having a reaction to the medicine might be something like 0.10 or 10%. All right. I want you to notice something about this sort of an experiment. You could get the probability of having a reaction by doing excuse me, by doing an experiment. So you give your medication to 1,000 people, and 100 of them have a reaction. So 100 out of 1,000, we get the probability of having a reaction is 10%. Something like this, right? Now I hope that you've implicitly seen that when we do this notation, the probability of an event, we're going to label it as capital P, and then in parentheses, we're going to get whatever the event is, whether it was rolling a 2 or having a reaction or something even more complex. Now, the two things that I showed you were very different ways of getting probabilities. One, when I was rolling the die, I was actually calculating what's called classical probability. So the probability of getting a 2 on a single die is 1 in 6. That's the idea of classical probability. It says if we have a 6-sided die, all of the outcomes are equally likely. And so to get my probability, I take however many things that were in here and divide it by the total number of outcomes. So all my outcomes in my event divided by the total number of outcomes. Let's do, if you rolled a die and you said, what's the probability of getting an even number? Either a 2, 4, or a 6. Well, there are 3 even numbers out of 6 total. So 3 out of 6 is the probability. Now, I want to be very clear here. In this class, we do not have to reduce our fractions. Okay, in fact, we'll see there's some good reasons not to reduce our fractions in a little bit. Okay, but classical probability uses equally likelihoods. Now, that's contrasted with the empirical probability. Empirical probability uses collected data to determine probability. So, my example when I did an experiment that 10% of people who take this medication have a side effect, that's empirical probability. All right? Empirical probability. Basically, think about empirical probability, there was probably some sort of experiment involved to get the data. All right. There was an experiment that happened that they collected the data. So they gave a lot of people medication. Some of them came back and had a reaction. Some of them didn't. All right. So it uses collected data. Now, obviously, there are certain things, certain outcomes where you have to use empirical probability, like the medication example. All right, you have to use, you can't say everybody's equally likely to have a reaction. You have to use collected data. All right. Now, there's another type of probability that you probably want to avoid. It's called subjective probability. All right. Those are things like the probability of the Tigers winning the World Series. All right. If I say the probability that the Tigers win the World Series is 10%, then that's subjective probability. That's an educated guess. Now, I want to say something about this. Just because it's an educated guess does not mean that it's a bad one. All right? Now, if I had to predict what's the probability that the Tigers win the World Series this year, I would probably do a pretty bad job of it. However, there may be some sports analysts who could give a much better educated guess. All right? So just because it's an educated guess doesn't mean it's good or bad, or it's close or far away. But it does mean that it's somebody's guess. All right? Another type of subjective probability, if I said I have a 3% chance of dating that person over there, well, that's subjective probability. Or my chance of going home tonight and having to wash dishes being 80%. That's subjective probability. Things of that nature. All right. Now, in the previous 2 slides ago, I should say, I talked about the notation that probability of an event looks like a capital P with the event in parentheses. So it's kind of like function notation. All right, you should have seen function notation by this point in your career. So function notation, or at least is very similar to function notation. Probability of the event is equal to, and we always have a number out here, and this number is our probability. Now, one thing about this number that I want to emphasize is that it always has to be somewhere between 0 and 1. All right? Because probability can be translated into percentages, right? It's a likelihood. So you can have anywhere from 0% to 100%, which as a probability gets translated between 0 and 1. So probability always has to be between 0 and 1. There are often times you hear people will say things like, well, I gave 115%. And to those people you should say, no, you didn't. All right? So they never, you can't give over 100% of anything. So let's, I'll leave it at that. But I hope you see some of the different looks, or at least the different notations of probability.